Thank you, Inez. You know, when I realized this morning that my favorite Keanu Reeves movie was Speed, it took some adjustment to get used to the idea, but I'm fully on board now. So, like the main plot point of that movie, I will try to maintain a constant pace because otherwise this 10-minute talk will not be 10 minutes. So let's get right to it. Query, introspection, ID, and underscore type name, which the dictionary defines as probably a typo. These are 4 key concepts that give superpowers to product managers and designers, and they're part of a technology called GraphQL. GraphQL is an open source query language for your API. Now, in the next 10 minutes, you will need no prior knowledge of GraphQL, but I will assume that you and I share the common value of wanting to empower our cross-functional partners. And I hope that by the end, you walk away with a few new ways to consider or reconsider GraphQL, because it does solve real problems for designers and PMs. But first, I'll introduce myself. Hi, I'm Jeff. Jeff Auriemma. My pronouns are he and him. I have no superpowers that I'm aware of, which is probably for the best, to be honest. I do have 3 children, though, and I love to make coffee, and I like to bake, and I like to hike. And I also work at Apollo as an engineering manager. Now, I promised that you wouldn't need any GraphQL knowledge, so I owe you a quick rundown of the basics, as it might serve a designer on your team. So let's say, for the purpose of this talk, we work on a music app, and we'll take a peek at how data could get from the server to the UI of this music app. In a traditional JSON API, here's how that might look. It's a humble GET request to a REST backend, and whatever the server decides is a playlist resource, you get back as JSON. And here's a request to a similar backend, but this backend is a GraphQL service. You'll notice a few differences. There's a request body that looks kind of JSON-like, it's nested a little bit, and whatever fields are listed in the request get included in the response. GraphQL API responses mirror the shape of the request body. That's the basic premise of a query. It's the most common operation in GraphQL. GraphQL queries are extraordinary. They give you all the data you need and nothing you don't. Here's what composing a query might look like in a GraphQL IDE. Note that every single piece of available data is easily discoverable in the left pane. In the center, we can construct our query, and we can see the server response in the right panel for that given query. Engineers love this, and it turns out designers can love it too. It's great for the creative process because it resolves one of the key points that designers deal with, which is knowing the constraints of the system that they're designing for. Here's an example. Our designer is taking a look at this playlist page. They're trying to ensure that their design covers all the different corner cases that we love to talk about and bring up in those design reviews. And a question pops into their mind about playlist cover art. Because while we're clicking through, all these playlists seem to have images, but will that always be the case? Is that a rule? Is that a constraint? If they're not able to self-serve or rely on assumptions, they need to ask, right? So they message their engineering colleague in order to get the answer. Now, we've all been on one side or both sides of this conversation at some point, right? The question might be simple, but the answer could be not available for any number of reasons. Engineers are walking documentation in teams, and we're moving targets, and our uptime is not 3 nines, so we're also bottlenecks for information, right? And that can lead to stress for the folks who rely on us to help them to do their best work. GraphQL IDEs can resolve this pain point. They're called IDEs, but don't let the name fool you. They're really usable for non-developers. You can grant access to your cross-functional team. With GraphQL, our designer can search playlist directly. They can find the images field and get the answer to the question they asked themselves on demand. Now, API documentation tools, there are plenty of them out there, right? But GraphQL can do this all by default out of the box through a thing called introspection. Basically, your GraphQL API doesn't just give you your data, it can also tell you about itself. All the reads and writes that it's capable of, its hopes, its dreams, its favorite Keanu Reeves movie. Introspection is made possible thanks to the schema document, a required part of a GraphQL API. The code, the type annotations, the descriptions, they all ship together. So GraphQL services are self-documenting by default. Every single GraphQL API will be able to be explored in full by an IDE like what we saw earlier. And that's why when your engineers adopt GraphQL, they're giving superpowers to your designer. They're always looking out for ways to make your app better. And in order to do that, your designers need to know the full extent of the data that's available to them and how it can be modified in a structured way. GraphQL brings those insights straight to your designer's fingertips with no overhead. All right, so let's keep this bus going with some GraphQL basics, this time from the point of view of the PM. And we're going to talk about the concept of ID. And I want to set this concept up a little bit by talking about REST APIs, because the way that they identify resources can actually be really limiting to a team that wants to stay agile and iterate quickly. The idea of what constitutes the thing that we call playlist one today is tricky, because when we get a playlist, we're only rarely asking for just stuff from the playlist table, right? In this view, we will need songs data, we'll need album data, artist data. One design decision that teams make is to eager load the nested data on the back end. Now that's fine, but it has longer term implications. Basically, you're making a bet that every time you ask for a playlist, you're also asking for the songs that are in that playlist. But let's tap on a song in the UI, look at something about us, and fetch song 2. And wouldn't you know it, we need nested data in this resource too. A lot of it, maybe all of it, was already fetched, but this is a song resource, not a playlist resource. All right, in that song resource, let's go ahead and tap on an album, Discovery. More nested data. Now, we already knew the artist, but hey, this is an album resource, right? You get the picture. Every one of these API responses is tailor-made to a specific page. That's a commitment. Let's round it out and tap on the artist page. Take a look at Daft Punk now. More nested data. Again, it's not wrong, it's not bad to do this, it's just committal. And it's a bit wasteful too, right? We've requested the same data multiple times now in different forms. What we call playlist 1, song 2, etc. today works for our users, but users change. And that presents a real challenge to product managers who want their team to be able to respond to and design for that change. Here's a classic example, right? The A/B test. Another totally real conversation between a PM and an engineer here. Identities have been changed to protect the innocent. The PM wants to run an experiment and wants to know how long it'll take in order to add tour dates to an artist page. Now, this can present a real challenge to the boundaries we've drawn around our API endpoints. Where do tour dates fit in with our current structure? Now, this is my talk. I get to make up the rules in this fictional scenario. So let's say that the tour date service is slow and bogged down by technical debt. Our engineer knows this. They figure eager loading is an option, but it's risky. So they will duly make a conservative estimate and hope it goes over well. But we'll step into the PM's shoes in a moment here. Again, fictional scenario, right? But you can substitute in this hypothetical scenario for something you've worked on in your career. The point is that estimates can be tricky, and it can be politically tricky if they're not what people might have expected for whatever reason. And this can stress out the folks who depend on us to design our systems so that they can meet the challenges of today and tomorrow. So that engineering problem with nested data that we talked about earlier, that's actually a product problem too. In REST APIs, your views tend to get coupled to your backend's design, and that can make iteration difficult. And here's where _ type name, not a typo, makes a difference. It's the part of GraphQL that untangles your API from your UI. Let's see it in action in our music app, and we'll go to a playlist view, and we'll render that view using the data from this query here. Note that we're asking for an ID and a type name for each entity. And the GraphQL API gives back this payload. We get a type name field to tell us what kind of object each one is, and an identifier field, an ID. And this allows us to identify individual objects rather than whole endpoints by ID. So that data we fetch can be normalized and stored in a flatter data structure. See how playlist 1 has a reference to song 2, right, instead of nesting it in there, and song 2 has a reference to album 3 and artist 4? Our data is no longer trapped and duplicated in deeply nested JSON payloads. So every subsequent lookup of the data that we already have in memory doesn't go to the network. The GraphQL client just renders the data that's already in the cache. And that allows us to stop worrying about how our backend is structured, because once it reaches the client, it's normalized, so we can be more agile with product decisions. Normalized caching is a typical feature of GraphQL clients, and it's made possible by ID and type name, classic super friends. Together, they defeat an entire class of problems that plague fast-moving product teams. GraphQL also has these great built-in directives that are ideal for A/B tests. So all I have to do is write @include next to tour dates and pass in a Boolean flag. No more ugly conditionals in our controller code and tests in order to get that data to our UI. Also, one GraphQL API can service any number of different client applications, Android, iOS, web. You can structure your queries and experiments however each app needs or doesn't. And there's batteries included experiment cleanup with the @deprecated directive to signal what fields might be going away in the future. Today, our app looks like this. Tomorrow, our users might need something different. And that makes GraphQL a very capable tool for delivering the same experiments faster, which makes PMs happy. With GraphQL, your API won't be the supervillain of your UI. You can structure a query to match your user story. You can conditionally include and deprecate fields as you learn from your users. When your engineers use GraphQL, they're giving superpowers to the product manager. So these 4 words, query, introspection, ID, __ type name, not a typo. These are the concepts that make GraphQL so super for your whole product team. Consider giving it a fresh look. Thank you.